All right, hello everyone. This is um, airflow, ANSYS fluent simulation around an airfoil. Um, so in this video, I'm going to show so you get the velocity contour and pressure contour at 0 degree and 10 degree angle of attack. If you're doing the project, you're going to have to do the same thing for to positive 21, and then with an increment of 3 degrees for a Reynolds number of a million. And obviously air density is 1.2, viscosity is 1.8, and then, okay, so in order to get your NACA 2415, so you just search NACA 2415, that, uh, and it's gonna pop up this one. So you wanna click on the one that says generator, um, because of this important distinction of like when it pops up, you wanna do 200 points instead of 81, and then you wanna close the trailing edge here. And then you're gonna click plot, and then now this is like a sharper edge. So you're gonna send to Airfoil plotter, and then once we have this all here, remember that the chord length should be 1,000 millimeters because this is in millimeters. So you want it to be 1,000 so that it's 1 meter. So then you're gonna click on CSV file of coordinates, and it's gonna save an Excel file. Open that Excel file, and it's going to look a little something like this, except for these 5 columns. These 5 columns you're going to have to make yourself in order to be able to import it into ANSYS, because ANSYS is not going to like this. So first thing you want to do is you want to eliminate this 201st coordinate, because essentially it starts and ends here because it closed it. But ANSYS doesn't like 2 points occupying the same space in the geometry. So if you import it like this, it's gonna scream at you. So please don't do that. So then you want to do 5 columns. It's going to be group number. For all 200 points, it's just 1. And then for points, you're going to number them all to like all the way to 200. And then, you just do 1 down 2, and then highlight this, and then click and drag, and it's going to number all of them like that. So then you just you copy paste all of this here, and then for the Z, you just do 0. And then don't do this. Don't copy these. Just copy the numbers. So you just want to highlight all of this, and then you want to do Control Copy, and then you want to put this into a Notepad file. So you're gonna Control, and then you're gonna paste it into a Notepad file like this. And it's gonna have all of this data. It should look very nice like this. And then you're gonna go into File for Notepad, and then you're gonna click Save As, and then make sure you save it somewhere that you know you're gonna be able to find it. So with that being said, we can go ahead into the geometry. So you can control click like this, and then go into the geometry like this. And then we're gonna right click on geometry. We're gonna do new design modeler geometry. That one's the simplest to use. Okay, and so now that it's pulled up, you want to click on the positive z-axis and do all the first things first. So positive z-axis, and then you click on units and then millimeter. Make sure you do that before anything else. Click on the XY plane. And then we're going to zoom out a little bit like this. It's okay. And then we're going to go ahead and click concept, and then we're going to do 3D curve here. And then where it says coordinates file here, you're going to click on these 3 dots. It's going to pull up this window. You want to go to where you saved it. So I'm going to go here, ANSYS projects, and then, so mine is this one, video NACA 2415. And double click that, and then it generates this nice curve. Like that. And so we're gonna click on top here, generate. So it generates this. But a warning though, let's rotate this a little bit. So if you go here, right, you zoom in to the trailing edge here. Since we deleted that last point, this is not going to close and it's not going to create your surface that you need. So what we're going to do is we're going to go ahead and we're going to go into concept. We're going to do lines from points here. And so when you hover over the end of these lines, they show like this little point right here. So you're going to click that one and then control click on the other one like that, and it creates that line. So you're going to click apply. It should be highlighted light blue, and then click generate. So now we have that. Don't zoom out just yet because we have like 2 more things to do here. So what we're going to do is we're going to go to concept, and then we're going to do surfaces from edges. So you're going to click on the airfoil here.
All right. Sorry about that. My microphone died. But so what you're gonna want to do, we created the surface here. Um, but we still need this edge right here. Um, that we need to merge. So what we're gonna do is we're gonna go into tools and we're gonna click on merge here. So merge, and then we're gonna click on the airfoil edge first, and then we're gonna click on the extra line that we did. And I click apply. I want to switch this minimum angle to 0 just because this angle is really small. So there we go. And then we're gonna click generate. And so now when you hover over and you click on it, it should be all, merged, one single thing. So the reason for that is because ANSYS treats that in the meshing, it treats that as an edge, and in the meshing it's gonna scream at you that it doesn't know what to do. So um making things easier. So then we're gonna go ahead and create a sketch here. And so we are going to make the test section that we need. So we're going to do a rectangle, hover over the y-axis, click, drag so that it's right there, like in the origin. So we're going to dimension this rectangle to be a 10,000 by 10,000. So we're going to click on this, click on this here, and then we're not going to do that yet because we need to constrain it with symmetry. So we're going to click on the x-axis here, click on the top line, and then bottom line, and then now it's symmetric, so we're good. And then now we can go ahead and dimension it. So we're going to go down here, we're going to edit the dimensions. We're going to do 10,000. 10, 1, 2, 3,000. There we go. So now that we have this, we're going to do the kind of inlet reference section. So we're going to go ahead and draw, and we're going to do an arc by 3 points. We're going to click on the top point here, the bottom point here, and we're going to click on the perpendicular, right, like that, and so we should be fine with that. And then we're going to modify, we're going to go to trim, and then we're going to trim this line, we don't need it, and there we go. Now we can generate this surface, so we're going to do concept. We can do surfaces from sketches, and then you're going to click on sketch 1 down here in the tree, and then click apply. I'm going to click generate, There we go. So now we have this, and we have two surfaces. That's not gonna do. So we need to subtract one surface from the other. And the way we do that is we create up here, we create a Boolean right here. And then instead of operation unite, we're gonna do operation subtract. And so for target bodies, we're gonna click on the big face here. We're gonna click apply, and then tool bodies, we're gonna click on here, and then you're gonna click down at the left, bottom left here. You're gonna click on this, and it's gonna highlight the airfoil surface. You're gonna click apply, and then you're gonna click generate up here, and there we go. So now it cut out the section where the airfoil was, which is great. So now that we have this merged, we have, and the surfaces, the one surface made, we're gonna go ahead and create another sketch. So up here, create another sketch, and then we're gonna make some lines. So we're gonna make a line here that's like intersecting a part of the airfoil, like that. We're gonna create another line over here, vertical, and then we're gonna make a line that's gonna be on the x-axis. So here, here, there we go. And so we're gonna dimension this line here. We're gonna dimension this line, and we're gonna make it touch the. So I'm zooming in here. We're gonna make it touch the trailing edge. So we know that that's at 1,000 after the x is equal to 1,000. So I'm gonna switch that to being 1,000. There you go. So now it's touching the trailing edge, which is what we need to basically you're gonna see. So we're gonna click on modify, and now we're gonna click extend, and then we're gonna extend all these lines so that they're touching the outer edges of this like test section. So now that we have this all the way up and running, so now we have to go to concept, and then we're gonna do lines from sketches. You click on that, you're gonna click on sketch 2, it's gonna highlight all of these yellow. You're gonna click apply, and then you're gonna click generate. So now every line should have an arrow pointing to some direction. So you can see that there. That's a good indication. Now we're gonna project these lines onto this surface on the face. So like this surface, so that we can split it up into different faces, which is what we need for the mesh. So in order to do that, we're going to tool, and we're gonna do face split. And so target face, we're gonna click on the test section face, and then tool geometry, I'm gonna click up here. It's gonna be edge select, and then you're gonna control click on all the lines, click apply, and then click generate. So now if you go up here and you do face select, we should have 6 faces that we just created, which is really cool. So now we're gonna do a couple more things. So before we move on, so if you zoom in here, um, and you do the edge select, these are 2 different edges. And when you do the meshing, you need to merge these, or else ANSYS will again scream at you, and that's not pleasant. So we're gonna do tools, and we're gonna do merge here, and then we're gonna control click these edges here, and then you're gonna click apply, and then you're gonna generate, and then now it should be one edge there. And then so we're gonna zoom out, and then we're gonna zoom back into the bottom part. This one needs to do the same. So we're gonna go to tools, I'm gonna do merge, and it's gonna be edge select. You're gonna click on this edge, control click here, gonna click apply, and then generate. So now if you click on it again, it should be one line, one edge. All right, and I think that's pretty much it. The last thing we need to do is on this tree right here where it says 2 parts, 2 bodies. You're gonna click on the plus sign. You're gonna see this line body here. You're gonna right click on it, and then you're gonna click on suppress body. You're gonna do that because ANSYS doesn't like meshing two bodies. Like if it's a line and a surface body, ANSYS doesn't like meshing both of them. So it's gonna give you like, it's not gonna work. It's gonna give you a bunch of errors, and it's gonna throw a fit. So don't yeah, just don't, please. Um, so yeah, we can go on to the mesh now. Click edit, and it's gonna take a little bit to just pop up. Hopefully it doesn't take too long. There we go. So now when it pops up, we should see like 6 faces. There we go. That's beautiful. So we have 6 faces here, and we're all ready to mesh. So I'm gonna go a little bit fast on the mesh. So please bear with me. Pause if you need to. So we're gonna do 4 edge sizings. So we're gonna insert and then edge sizing. We're gonna do 4 of these. So and then one mesh, face mesh. So we're gonna edge select, and then we're gonna click and drag all the way here. Geometry, click apply. Element size no, we're gonna do number of divisions, and then we're gonna do 200 divisions, and then capture curvature, we're gonna do no, behavior soft is fine, and then we're gonna introduce bias. Either one of these two is fine, and then bias factor 50,000. And then we're gonna have to check each of these individually to see which one of these needs reversal. So click apply. We don't want this one. So this one was fine before. This one was fine before. This one's fine as well. This one needed reversal, so I'm going to control click that from now on and just make sure the other one, this one needed correction as well. So I do that. There we go. That one needed correction as well. So click on all of these. Click apply, and then there we go. So all of these needed to be reversed, so it should be getting finer. The elements should be getting like smaller and smaller and smaller, the distance between them, as you get closer to the airfoil, which is what we need. So, and then right click, insert sizing. We're gonna do these top 3 here. Click apply, element size. We're gonna do number of divisions, 200. Capture curvature, no. Behavior hard, and then bias is going to be 500. Oh wait, hold on, sorry. Right here, and then bias is going to be 500 for the factor, and then this bottom one needs to be reversed, so we're going to click on that, apply, and all of this should be fine. Then we're going to go on to our third one, the sizing here, and then we're going to do this small section here. So we're going to do this one, and this one. All of these. Apply. We're going to go from element size, number of divisions. We're going to do 150 here. Then capture curvature. We know. Behavior hard. We don't need any bias, so we're good. Then right click insert, sizing. And then we're going to do these circular ones, and then you're going to zoom in and you're going to click on these edges of the front of the airfoil like that. And so the reason this happens is because when you're meshing, every face needs to have the same amount of sides. And with this circular face, with these circular faces, they only have 3 sides. So this line needs to intersect the airfoil in order to give these circular faces a 4th edge. So that way the meshing can work. So we're going to do number of divisions. We're going to do 150 as well. And then capture curvature, no. Behavior hard, no bias, so we're good. And then lastly, we're going to insert, we're going to do face meshing, and then we're just going to click and drag through all the faces. Click apply, and then we should be all set. Now you can click generate, and then it should mesh very nicely. Should look, there we go. And then this warning don't worry about it. The meshing works perfectly fine. This is what we want. So then last thing we're gonna do with the meshing here is we're gonna name our um, edges that we need. So I'm gonna control click, we're gonna do edge select, you're gonna control click all of this. Nope, not that one. We're gonna do all of this. And all of this counts as our inlet, just because um, it would be a reason to cry if we just switch the geometry every single time we have to change the angle. So instead of doing that, we're just gonna change the angle from where the air comes from. So 0 degree, the air is gonna come through here, and if not, it's gonna come through here. So in order to do that, we need to make all of this the inlet. So we're gonna do N, we're gonna do inlet. I'm going to control click all of these edges in the back. We're going to click N on our keyboard, outlet, and then we're going to click on the edges here of the airfoil. So here, and then zoom in so you can click on these two edges. And then you're going to click N, and you're going to click airfoil. There we go. And then we're done with our meshing stage. So make sure that your name selections are good. Outlet and then airfoil. There we go. Our mesh, and then we're going to minimize this. We're going to right click on our mesh in the workbench, and then we're going to update. And once it updates, we're good to go on to our setup. Then we're going to click edit. And then when it pops up, you want to do double precision and then 3 solvers, or 4. The reason being it's going to take a long time to process this data because especially with the higher angles of attack, you need a lot of iterations to calculate in order to reach a good convergence. For the lower angles of attack, you reach convergence pretty early, but I think it only happened for me. It only happened at the 21 angle of attack, 21 degree. I needed like 3,500 iterations for the calculation, and it still didn't converge, but it gave me a pretty accurate answer. So like the more iterations you do in that case, the more accurate your answer is going to be. So this is what we need. Awesome. So we're going to click OK. And then first thing we're going to do is we're going to go to materials, fluid. We're going to change our air properties from, so 1.25, we're going to switch to 1.2. And then from this number in the viscosity, we're just going to do 1.8 like that. So you're going to click on change and create. You're going to close that and minimize this. And then what else do we need? We need to change our inlet conditions. So for the inlets, we're going to do, instead of magnitude, since we're changing the angle, we're going to do components, right? So for the velocity, in order to determine that, you just need to use your Reynolds number. So if you go here, you need to use your Reynolds number along with your chord length, which is just 1 meter, and then your air density and your viscosity to solve for the velocity that you need, and that comes out to be 15 meters per second. So you do that, and then you apply. And so the reason why we have components here, I'll show it really quick, is so here I have like all the stuff that you kind of need. So the total velocity here is going to be 15, and then so depending on the angle of attack, you need to separate it into components. You need to take the cosine and the sine of those angles, and then in Excel, I have Excel does cosine and sine in radians. So I have all the angles of attack here in radians. I converted them all into radians. And so that gave me the X and Y components that I needed. I have them here in degrees just for the graphs. So that way it like looks um better to look at than radians because this is kind of ugly to look at in a graph. So yeah, for zero angle of attack, we don't have to worry about the X and Y components, but for the 10-degree angle of attack, we do, which I'll show later. I'm going to click apply, close, minimize this, and then we are going to go right click on report definitions. We're going to do new, we're going to do force report, and then we're going to make one for drag and lift. So I'm going to do drag, we're going to rename this drag cof, and then we're going to click here on the airfoil. And then the X and Y components is here this is where we're gonna change later. Right now we don't need to, but I'll show how to do that in a second. So we're gonna click OK. So now we have that created there. Then we're gonna right click on report definitions again. We're gonna do new, force report, and then we're gonna do lift this time. I'm gonna click on the airfoil here. We're gonna rename this lift cof. And then everything's fine. We're gonna click OK. And then we should be good. Now we're gonna double click on initialization. And then for settings, you can do however many iterations you really want. The more iterations you do, the safer it is to like get more accurate answers. When I was doing it, I was doing 35, but we can do 40 this time. I'm gonna do apply, and then we're gonna initialize, and then it's gonna start off a little slow, and then it's gonna speed up in a second, in order to finish it. Then once it's done, we can do the calculations. Okay, there we go. The initialization is done. We're going to double click on run calculation, and then number of iterations, I'm going to do 1,000. Usually it converges before it reaches 1,000, so I'm just going to click calculate, and I'm just going to let you see that. And it's going to generate the plots for the lift and drag coefficients. So you get to see how the lift coefficient changes, how the drag coefficient changes, and then the scaled residuals. So that's pretty cool. And then you got the mesh there. So usually it converged pretty early, so like anywhere between like 30 and 40% of the iterations for the low angles of attack. It would say, oh, at a certain iteration, convergence was reached. So it's not going to need that many iterations uh, for the low angles of attack, but for the high angles of attack, like I said before, for 21 degrees, it takes longer, way longer. For me, it took 3,500 and still didn't. Actually, no, I think it was 400 or 4,000 iterations, and it didn't converge. Um, so yeah, just be patient. 4,000 iterations is perfectly fine. Even if it doesn't converge, 4,000 iterations is perfectly fine. See, there we go. So it converged at 79 iterations. So that's pretty good. So there's our drag coefficient plot here, lift coefficient plot here. But this is not what we need because this is just with iterations. How it changes with iterations, we need it with respect to alpha. So that's why we have that Excel part there. So we're going to go here to graphics, and we're going to double click on contours. And then we're going to do velocity contour, we're going to save and display, and then this is how it's going to look. So yeah, so you don't have that much flow separation here. And then you have the stagnation point here. You have kind of a dead zone, like really, really close here. But you're not going to have like a wake region, ideally. And then for the same contours, you can do pressure, and then you're gonna need all the pressures. So this is static pressure. There you go. And then we're going to need dynamic pressure, which should look the opposite of velocity pressure. There you go. And then the total pressure, there should be a drop near the, yep, there we go. So there should be a drop along the surface, and then like really small, like there, and then trail. And then cool. And so let me show you guys how to calculate the drag and lift coefficient. So with these report definitions that we had here before, you're going to double click on the drag coefficient. And so the components, the X and Y components are fine for now. And then you're going to go ahead and click compute. And it should show down here. So the coefficient of drag is, oh wait, hold on. You do need to change these, hold on. So these components here, so it should be, so yeah, so for the drag, it should be, that's kind of weird. So it didn't give me like a super accurate answer, for some reason. The drag coefficient, it should be these. Go ahead and compute again. Yeah, so that's a little weird, actually. Oh wait, hold on. I think, oh, the reference values. Ah, there we go. Yeah. Okay, so I'm sorry. So make sure you switch your all reference values before. So you can run the calculations again. Change your reference values um, from that from like the reference values default setting to the inlet. I forgot to do that. I'll do that in for the 10 degree. I apologize for that. And then for the lift coefficient, you just double click and then you just hit compute, and so then you should have a lift coefficient. So again, for here, I have it highlighted, so it's it's here. So your drag coefficient should look like this, and then your lift coefficient should look like this. So that's pretty cool. And then now for your 10 degree angle of attack, I have highlighted here. You're gonna have to switch the X and Y velocity components here. So we're gonna do that. So we're gonna go click here. We're gonna copy this, and then we're gonna go to boundary conditions, inlet, and you're gonna switch this to that X component, and then you're gonna go. Oh no! Wait, hold on. And then this one here, like that, and then I need to fix this one. Oh no, that was right. Okay. Okay. Okay, just making sure. And then you click apply and then close. And then for your drag coefficient and lift coefficient, you need to modify these force vectors as well. So you just put this side to side really quick just to make sure that I got, so, oh, never mind. So for the force vector here, what we're going to need to do is we're going to just use these X and Y components here. So for 10 degrees, your X is going to be this one. And then for your Y, it's going to be this one. All right. And then for your drag coefficient, this is fine. So you're going to click OK. And then you're going to click compute. And so that's what your drag coefficient should look like. It should be down here, and then you put it on your Excel. And then for your lift coefficient, it's going to be the negative of your Y coefficient, of your Y component. So it's just going to be this sine 1 but with a negative value. So we're going to go here, negative your y value, like that. And then so your y value is going to be your positive x value here. So it's going to be this one. You're going to copy, and then you're going to pull this up here, and you're going to paste it like that. And then you're going to click compute, and then that should give you your lift coefficient. And then so you do, so you just rinse and repeat with all the other angles of attack. And then let me just initialize this once more and then run the calculations. Oh wait, hold on, I didn't run the calculations. You're gonna have to do that again. So yeah, so it's good that you do that before, because then you can like run the calculations and then just like double click on them, compute and stuff like that. So it's fine. So here we go, hybrid initialization, and then the number of iterations 1,000. Let me run this once more. And then so once it's running, it's gonna, again, it should converge before it even reaches 50%. It might reach 50% a little bit. But yeah, so I'm gonna mute, and then feel free to fast forward to when the calculation is done. All right, so the calculation is done, and then you see like a little change here. So if you go to the contours, you double click on the contours, and then you switch it to velocity, you're going to be able to see the, yeah, so this stagnation point right here, this is where the flow kind of meets the leading edge. And then you have a little bit of flow separation starting from like around here. And you have a very small wake region, and then you have like the accelerated air going through here. And then for the pressures, pressure, do static pressure, so it should look like that. And then your dynamic pressure, like that. And then your total pressure, which I had before, should look like that. And then again, let me just do the drag coefficient. So again, we changed it before, so that should be fine. We compute it, and then there we go. So this is your actual, drag coefficient. So it should be that one. And you cancel, and then double click on your lift coefficient, and then, okay, so yeah, so your lift coefficient should, again, let me do that again. So it should be the negative for your x, should be the negative of your y coefficient, like that. And then for your y, it should be positive of your x coefficient, like this. Like that. There we go. So we're going to click OK to save that, and then double click back on the lift coefficient, and then click compute, and then there you go. So this is the lift coefficient that should it should look like that, which is fine. That's what I have here on the lift coefficient. And then on Excel, you just do lift coefficient divided by drag coefficient to get your CL over CD, and then you just plot those here, and then you do the XFLR5 analysis like that, and then that should be everything. Hopefully it was helpful. Thank you for your patience. I didn't commit maybe a couple mistakes, but yeah, so now you know for when you do it yourself. And I hope it goes well for you. And have a good rest of your day.